It's definitely a sigh of relief, and it feels.
You want to know your greatest strength?
Boyish charm, good looks.
Critics are raving about Tom Clancy's Without Remorse.
Has it occurred to you that John Kelly has done something we can't? They're gonna play by my rules now.
Tom Clancy's Without Remorse. Rated R. Watch now. Only on Prime Video.
We're gonna smoke again. We're gonna smoke again, guys. He's a Lotus Orb on the Venomancer. Lotus Orb on Venomancer.
Hey guys, what's up?
You have Hawks? Oh, they're TPing out and shit. We're obs, right? We're smoked. Okay, I'm running out. Fucked up.
Ouch.
I don't know. I'm sure the Shaker will eventually cast one spell that's relevant to his game. I'm not sure when that's supposed to be, but I don't know. At one point he'll have impact. When the enemy has 5 heroes in the same spot, he'll act on them.
Hey Nicholas, what's up?
Oh.
Yeah, we're just chilling out for now. You know, we're just waiting like for a couple minutes, wait for people to get in, and see what's up. But yeah, I'll answer any questions you guys have. For the people who are just joining, hello, welcome. My name is Edward. I am a senior software engineer, and I used to work at Apple. Now I currently just work at Uber, and I focus on helping people improve at their careers and at coding interviews in general and land their dream jobs. So if you guys have any questions about the industry or how things work, I guess, yeah, I'll be happy to answer them. Yeah, everything's fine. Nice to see you. Yeah, thank you. In the meantime, I'm just kind of like watching Dota. See who shows up. I guess in the meantime, I should browse Hacker News, see what new things is getting really interesting. What the heck is this? 1/3 of Basecamp employees accepted buyouts today after a contentious all-hands meeting. What the heck? Wait, hold up. What the heck just happened here? Why is there why were employees bought out? And why were they, what? Oh god, I'm using Bing, hold up.
Go smoke.
Okay, hold up.
Smoke him.
Wait, holy shit, holy shit. Holy shit.
There's a big
Base
pretty big
camp
kill.
implodes
Center.
as employees. I gotta mute this. Holy shit. Base camp implodes as employees flee company, including senior staff. All right. Why the hell are so many people leaving? New philosophy that prohibited his societal and political discussions on internal forums. The company would offer severance packages to anyone who disagreed with the stance. Holy shit. It's like, yeah, we're not gonna let you talk about social or political things, and then employees are leaving over that? Okay, that's really fucking not good. When your senior staff are leaving over this, holy shit. There has to be more than that. It's like, it's not just like talking about the discussions, but doing away with paternal benefits and committees is actually probably the biggest one, I think. This is just a straw that broke the camel's back. Like, there's no freaking way. Holy shit. Like, I don't know, man. When I see shit like this, when I see, like, when CEO ban political discussion and then people leaving over it, it's really hard for me to really say whether or not that's justified. Hey, Minty. Actually, what does Basecamp do? What exactly? Oh, project management and team. So it's basically like Jira, I guess. But damn. I did not act. Holy shit. Okay, let's see what Hacker News says that. This thread is paginated, so you see all the comments. It's all about power. Yeah, this makes more sense. Hold up. The top comment here. I don't think it's really about making fun of people's names or Holocaust references. It's about power. The managers at Basecamp were unhappy that their employees asserted power over them in the workplace and decided to assert their own power in turn over what they saw as their personal fiefdom and retract some of the freedoms that they had so graciously granted their workers, because those ungrateful workers actually expected them to live up to their words about openness and owning mistakes. No, that makes sense. At least 1/3 of the staff, when confronted with their true relations with the management, then decided to quit. No, that absolutely makes sense. When you're a company that preaches openness, but then you ban political discussions, that cuts both. That cuts in a really bad way. Flame works to create a hostile environment. That's why Hacker News bans political flame wars. I mean, when you talk about societal and political things, I mean, yeah, that's going to be a catalyst for taking a look. No, sorry, it's going to be a catalyst for getting heated discussions, of course. But we're all human. We all have strong beliefs on things. But it's like we can still work with each other despite them. That's what professionalism is about. So I'm really believing that there's a whole lot more to this. It can't just be a banning discussion. There has to be like some back and forth between the employees and management. The politics angle has been a red herring. Okay, red herring, yeah. The same contentious discussions would have happened had this policy already existed, okay? Okay. This might actually be more. I actually want to read the original statement, but I think this one also makes sense. That their 6 policies just mean that, hey, yeah, in case shit goes south, then Basecamp leadership is the one that arbitrates. I mean, it's not bad, but it's just like probably management put employees in a way that made them feel like Basecamp was the only solution that they had, the Basecamp management, and that the Basecamp management was also guaranteed to be dislikable. Actually, hold up. Let's actually read what the heck they just said. Okay, let's read the blog post. Changes at Basecamp. We treat our company as a product. It's not a rigid thing that's malleable, that evolves. We aren't stuck with what we have. We can iterate what we want. Just as we improve products, we can iterate on our company culture too. Okay, fine, fair. Every company goes through a change. It was saying some internal company changes, which, in taken in collective, feels like a full vision change. There's an announcement. Okay, whatever. Yeah, blah blah, yada, motherfucking blah. Some changes are accepted. Deal breakers. The same is true when changing your company, except that companies are employees. Okay, there are too many perspectives, individuals. Okay, sure. You know what? I'm gonna skip all this pretense. It's really annoying to have to live by this, or to read all this. We want different things. Fine. Yeah, I get it. I get it. People discuss shit, and the conversation goes nowhere. It's a goddamn waste of time. I understand this. Wait, hold up. I just realized I'm leaking water on some shit. Give me back. No. Well, you know what? I guess it's 8 p.m. I guess we should get started. All right, so tonight we're gonna continue with basically part 3 of this coaching series that I've done with this particular student. We'll just call him Devin. And yeah, he's been on stream weekly for the past 3 weeks. If you want to see his previous sessions, you can check them out in previous streams. But hopefully today we get to see if he has made any improvement from the last 2 sessions. So with that, let's bring him in. Hey, hello?
Yo.
Oh, wait, hold up. You're routed through my monitor. Give me a sec. Okay. Hello?
Hello.
All right, there we go. Cool. Sorry. You kind of cut out. My gear just went like crap for a second. Could you say what you're saying before?
Oh yeah, I was just saying hello.
Okay, what's up? Yeah, how's your studying been going?
Oh, I'm losing confidence by the day.
All right, what happened?
You just more and more things pop up that you don't know, and the date gets closer to the interview, and you're like, Jesus, it's going south.
How close to the interview are we?
Not next Monday, but the Monday after.
Okay, so we basically have like 10 days to get you to interview day.
Yeah, so I've been lightly touching DP like the last 2 days, and then before that I was pretty much just like trying to drill recursion after our last session. I feel like I'm a little better at recursion, but I don't think I'm at the right level yet still.
No, that makes sense. So tell me, what has been happening with recursion, and why do you feel like it's getting worse now, or what?
No, so I mean, I'm getting a little better at recursion, but I think because I've been starting to look at DP, that's why it's starting to feel like the feeling of dread. Okay. I think that's just the nature of like starting DP. But yeah, as far as like recursion goes, I feel like I still struggle to like map out what I want to like pass into the recursive function beforehand until like I kind of see it written. So I think that's kind of like my biggest flaw right there still.
Okay, so let's do this. I'll throw you a recursion problem just to see where you're at, and if I think you're fine, then we can actually talk a little bit about DP as well, actually.
Okay, as far as DP goes, I've done like a little bit of memoization and backtracking, and that's about it.
Okay, is that something you want to focus on this week, or do you want to still focus on like some fundamentals?
Let's do the recursion, like you said, see where we're at, and then we can go from there.
All right, sounds good. I'm gonna open up your doc here.
Yep, I'm in there on the last page.
Perfect. Okay. So
the only thing is like any DP that we do would probably be like less test and more teach, just because it's still like a new concept. So maybe it's not worth it. I don't know. We'll see.
Okay, yeah. Let's see. Okay, so I gave you the lowest. I believe I gave you the lowest common ancestor problem, right?
Let's see.
Yeah, or maybe you've done it. No, I haven't. So why not give you that one?
Okay, yeah, we did balanced trees. I don't think we did lowest common ancestor.
Okay, so then let me go ahead and start the timer. All right, and here we go. So let me under 50%. So given a binary tree, find the lowest common ancestor of two given nodes. So for instance, let's suppose I gave you the nodes 7 and 6, right? The lowest common ancestor between these would be 5. And then if I gave you 7 and 4, the lowest common ancestor of these would be 2. Do you understand why?
Yeah, so the highest node that both target nodes can traverse to.
Mm-hmm.
Going upwards. Yeah. So I think I understand the problem. So like if you gave me if you gave like 7 and 8, then the lowest common ancestor would be the root, which is 3.
Yep.
Okay. Let's see, where should we start? Let's go. So let's start with like we'll just take this example and we'll run through like the stack trace of one or two of these examples that we just laid out and kind of see what patterns pop up, and then we can go from there.
Okay. So I mean, you're running stack trace. That means that you have a function in mind, or something like that, or some variables in mind. So let's, yeah, sure, go ahead, do your thing.
Okay. So we're gonna start at 3. And from 3, we're going to traverse left to 5. So that's going to enter into a new recursive node 5. So let's take the example 7, 6. I'm going to put that down here. I'm going to work with that for now. So we traverse left to 6, and then we go to node 6. So now we're at node 6. So once we get to the target node, we want to, what do we want to do? We want to return something maybe. Okay, I'm thinking back to last time we talked about this, and it was like figure out the base case and the recursive relation. So I need to focus on that, I think.
Right. So what exactly is your base case, and what is your recursive relationship here?
Yeah, so the base case would be, so there's 2 base cases. Either leaf is hit, or target node is found. Those are the 2 base cases.
Well, you say you're gonna find. Why is this the base case? Yeah, why? When you say target node is found, are you finding one of the nodes or both nodes, or what exactly are you doing here?
Actually, yeah, target node wouldn't be work because if like you had like 7 and 2 or something, then you would like end up stopping at 2 and not going to 7. Which actually, side question: if you had 7 and 2 as the 2 nodes, would 2 be the lowest common ancestor?
Think of it would be 2 because 2 needs to share the ancestor. Keep in mind that these nodes only point to children, so you're only left with the adults. So in the case of 7 and 2, the answer would be 2.
Okay. So yeah, so the base case leaf is hit. So like if you came down, you hit 7. That's base case, and then you would go up to 2, down to 4. That's base case. So we need to do something to say we've hit the node that we're trying to hit. And we need to kind of like remember where that is in relation to the other node.
Okay, sure. But then what is, you're saying, talking about base case and recursive case. The base case for which problem? What problem are you trying to solve here?
So, all right, so let's take the example again, like 6 and 7 or 7 and 6. The base case would be...
No. What problem exactly are you trying to solve? Because you can have arrangement of nodes, but what is it that you're trying to get these nodes to tell you?
Trying to get these nodes to tell me their lowest common ancestor.
Okay, so what's the criteria for determining the lowest common ancestor?
The criteria for the lowest common ancestor would be what is the path to that node.
Okay, so path to which node? There's 2 nodes. Which node?
Yeah, so for example, like you would go 3, 5, 6 to 6, and then you could basically return back. No. Which node? I mean, either node, right?
Remember, I'm giving you 2 nodes.
Because you go 3, 5, 6. And 5, 2, 7. Oh, we're starting off with a banger already.
I want you to think about the entire problem holistically. At each node, what are you trying to evaluate? If I ask you to traverse to, what's the difference between being at 3 and being at 5? If I gave you 7 and 6, what is the difference between being at node 3 and being at node 5?
There is no difference.
Why?
Because you haven't found any target node yet.
But isn't 5 the answer?
Yeah, but you have no way of knowing 5's the answer without finding the lower nodes first.
Okay, so you need to find the lower nodes first.
Yeah, so what I'm trying to think about is like, how am I going to mark that I've found those nodes? So what I was trying to think about was like, could you return the path? But that won't work, I think, because then you'd end up with something like, you'd go down 3, 5, 6, and then you go like, you'd also have the path 3, 5, 2, 7, but then you'd go back up from 7 to 2 down to 4, and you'd return, unless like you, yeah, no, I don't think that would work. Let me write something out here. So like you'd have 3, 5, 6. And then you'd also have 3, 5, 2, 7. But then from 7, you'd go back up to 2 and then down to 4.
Don't worry about the implementation. Focus on like the happy case right now. Suppose you had some way of getting the path to the nodes. Let's suppose, just for instance, you had that. What then would you do with them?
So if I have the path to both nodes, I would want to then basically compare the two and find the latest common element. So like, for example, the 2 that I have written here, the latest common element would be 5. So like basically traverse backwards and find what's the first common element that hits when you're traversing backwards, and that'll be the lowest common ancestor.
Okay, I mean, that sounds reasonable. You're basically taking the path to each of the nodes and then comparing them to, and then seeing the last point at which they are the same.
Yes.
Okay, that's perfectly reasonable. Now, how do you plan on doing it, and is this the most efficient way of doing the problem?
In terms of efficiency, I'm not 100% sure yet. But generally, it would be like O of n, which generally is the best you can do for trees.
Okay.
So I'd be pretty confident in it, but I wouldn't say for sure yet.
Okay, so then what about the space complexity? What are you doing here?
Yeah, so the space would be... It would also be O of n because you'd be saving a list of potentially every node to compare against each other.
I mean, it depends on how you save it, and even then, it depends on how you're saving it, and how efficient you are with it.
Yeah, my thought is just like if you have like, yes, I mean, I guess it would be like O of log n because you'd only be saving like a single path probably.
Yeah, I mean, I would say that's probably the most efficient way of doing it. You push a node on, and then you pop it off.
Right.
Okay.
So
what I'm asking you is, can you do this problem without that space complexity?
Without the space complexity?
Yes.
If you, let's see. What I'm thinking is, and this isn't going to work, but it's just what I'm thinking right now, is like if you reach the target node, you'd like return true, and then you'd see if like another path returned true, but that wouldn't work in like the case where the two target elements are connected in a line, because then you have true on one path.
Okay. So, what happens if instead you were actually able to just, how to describe it? What if you could just eliminate having to record the path to begin with?
Yeah, I'm trying to think of a way to do that, and I'm not coming up with anything. Like I said, I was thinking about like the true false thing, but that wouldn't work in some of the cases. So I'm trying to think of another solution. I'm not coming up with anything right now, though.
Okay. Well, let's just go ahead and do this then. At least for now.
Okay.
Unless you feel confident in pursuing the idea more. If you're not, then it's all right.
I mean, I'm not gonna come up with anything at this point.
Okay.
Outside of what I have here.
Okay, that's fine.
Okay. So now we need to go back to thinking about what our base case is to begin with. So yeah, because you want to return the path back, but then the path also might get modified. So I mean, the base case is if you hit a leaf, but then there's another base case in there that I'm trying to think of.
You're talking about the base case and recursive case. Okay, fine. But the thing is that you still haven't told me how you're getting these paths. Like, okay, so let's say you get the path on the left side and you get the path on the right side to the nodes. Well, you need to be able to send that back somehow, right?
That's what I'm trying to figure out, because the base case is going to tell me like how to do that, basically.
Okay.
Because if I don't figure out the base case, then what's going to happen is we're going to end up in like the depths of Mordor, like we did last week.
Okay.
With all that nonsense. So, so I mean, I know how to get the path. It's just DFS 356, right? And then, but the question becomes, when you go 3527, how do you save that path when you go back up to 2 and down to 4? Because you're gonna end up popping off 7 when you go back to 2 and go down to 4. So then when you come back up to 5, you're not gonna have that 3527 path to compare, and you're not gonna see that you have the 2 numbers you need.
Okay. Yeah, so how do you save a list like that?
So I guess we could just like save every path from root to leaf.
Okay, but is there a better way of doing it? Like a smarter way?
Probably. So I mean, we just save the path if it contains the target.
Yeah.
So, like if we go 356, we're at a leaf. The path contains the target. We save that path. So we have like a list of lists, basically. So one of those is going to be 356. And then you'll go back up. So then that list is going to be separate. So you're going to have like a tracking list as you go down. So like as you go down, you'll have just like a list of nodes.
Okay.
So that it'll be like 3, 5, 6. And then when you hit the end and you do the comparison to see 6 is in that array, and you save it to that other list of lists, and then you back up to 5, you take 6 off of that list because you're going off that node, and then you go back down the other side to 2 and then 7, and then you'd end up saving that one as well.
Okay, so you're essentially talking about once you hit the node, you make a deep copy of the list.
Yeah.
Okay. Seems reasonable.
Yeah, so from that, we can say the base case is if leaf, or just like if node is null, then we're going to end up returning, but also another if statement in here that says like if tracking list contains target value. Yeah, and then if it does, that's going to end up add the path to the list. Yeah, so I think that's going to be our base case there.
Okay, so you're
I think there's... Sorry?
Okay. So you're saying like your base case is if there is no node. Fine. Okay. And all right, go ahead.
Yeah, because you want to go all the way down to the leaf in case the 2 nodes are like in line with each other.
Okay.
Yeah, I think there's some opportunity there to say, like, if you have the 2 paths to stop doing the DFS, I think there's some opportunity in there, but I don't think that's like part of the base case. I think that'd be part of the actual recursive relation.
Okay.
So yeah, so if we go 356, 3527, then we go back up, and then we can say, okay, so really quick, let me just write out like a. You're gonna hate me if I say those words. A function.
Wow, already? You still have all you've done is just write node equals null and then check the list and return. I mean, are you when you're writing the code, you're telling me, hey, I'm fully confident in my idea. Let's write it.
I mean, it's just pseudocode at this point. I'm just trying to like lay out the idea I have in my head for what I'm trying to do.
Press X to doubt, but okay. I mean, whatever you feel like you're comfortable with, man.
I mean, now I'm trying to think about how I can write out what I want to say without writing code, because I've already written code like this.
Okay, just write it verbally. Just tell me verbally what you want to do.
Okay, so get to the node.
Okay.
Then
when you say get to the node, which node?
So I mean, we're gonna start at 3.
Okay.
Get to the left node.
Okay.
So it's gonna be like it's just gonna be a DFS. Get to the left node. Get to the right node.
Sure. Okay, so you're at the
and
left
then,
node, and then what do you do at each node?
Yeah, so at each node, we're going to add the node value. Yeah, we just need the value. We don't need the actual node.
Sure.
To the traversal list.
Okay.
Then we're going to continue recursing down that left side. So, and then once we get to, yeah, so what we're not going to end up passing around. So where's that list of lists that I wrote down? List of lists. So this list of lists is going to be like a global variable.
Or
so when we get to the end, we're just gonna say like add that to the global, so that way we're not like trying to pass that around.
Okay.
So when we get out of the left recursion,
okay,
we'll go into. Do we want to go right into the right recursion? Because we might not have to. Because we could say like, if the global has 2 paths, figure out the LCA.
Okay, but you told me you're just recursing. But then, and you're adding node values. Didn't you just say earlier that you had to optimize this to pop off some nodes as well?
Yeah. So that's actually going to happen when you go down the right. So in between the two, you're going to end up popping off the left node. So every time you go down, you add the node, and then every time you come back up, you pop off the node.
Sure.
And then, so same thing for the right. I guess let's just figure out the left and right, and then I can worry about how we're gonna do the other part.
Okay.
Yeah. So we're just gonna do this like the naive way, or like the brute force way, where we don't exit early if we find the 2, and then we'll see if we can fit that in once we have the base layout in mind.
Okay.
So then once you're done recursing left and right, actually, if you're done recursing left and right and both contain, you wouldn't even need to pop back up. So what I'm just thinking about now is once you get back to 5, like you recurse left from 5, and then you come back up and you recurse right, and you're back at 5 after you're done recursing right. Now you have the two paths that you need in your list, in your global. So at this point, you can say, at this point, you can say return the LCA between those two lists.
Okay. But the thing is that that's only if you're at 5. What happens if instead you were at the root? You're at 3. What would happen?
Yeah, I was actually just thinking about that. So like if you said, like if you were at 5 and then you found the LCA, it's like, now what do you do? So so you would end up coming back up to 3. And now you're between the left and the right again, now that you're at 3. Bring this down. So we're between left and right. So I think this is what I was trying to think of earlier, is if you're if you come out of the left and you have what you need, now you can you can stop. You don't have to go down the right because you have both the values that you need. So basically you're always going to end up coming back up to the root regardless of where you find the path.
Okay.
So you can do something like if the global has 2 values, if the global doesn't have 2 values, then you can do all that. So the way that would work end up working too is like, so you'd have 3, 5, 6, and then you'd have 3, 5, 2, 7, and then you'd come back up to 2, and you have both values, so you wouldn't go down to 4. So you wouldn't ever do 3, 5, 2, 4 because you wouldn't need to. Yeah.
Okay, fair. Now, now what happens if, remember how we said if you picked 7 and 2, that the value, that the lowest common ancestor would be 2?
Yep, so the yeah, because then you'd have, like, if you'd have the list of lists, you'd have 3, 5, 2, and then you'd have 3, 5, 2, 7. So now we're kind of in the territory of trying to figure out, like, how do you calculate the LCA when you have the two lists of numbers. Because for 3, 5, 6 and 3, 5, 2, 7, you'd say you'd end up going backwards and finding the first common one, but that would work for that too. Yeah, you just go from the back and find the first common. So how do you do that for 2 lists that are different sizes?
Okay, so you're saying you want to terminate at how do you didn't even write that step down. So when you say you want to add this node here too when you're visiting it, because this is, you're adding the node to the traversal list. Okay, wait, I see. Well then what happens if I made it 3 and 5? Does your code still work?
Yeah, so when you come to 3, I see where you're going with this, because you would say you'd get to 3 and then you'd immediately start the DFS without first checking if 3 itself belongs to the traversal list. So let's see, what would make the most sense in terms of where to put that. Yeah. Okay. The problem is with the base case, I think, then, because it was stacked in that with the null. So you'd want to say.
So here's your problem. Your problem is that your base case, so-called, already adds the node to the list. So if, for instance, like I said DFS, and then like my list is nodes traversal, right? And then I have a node N here that I'm evaluating on. The thing is that your code has already set up node N to be in the traversal list. Why? Because if I go into the left node, you already added the left node's value to the traversal list. And then keep on recursing.
Yeah,
unless
but
this is the current node. Unless this is the current node, in which case, you still, and this is probably not the right place to put it. So when you say node value, are you talking about like the current node or the left node? Because I believe that you meant the left node.
I definitely meant the left node.
Right. So that's why I said, well, then based on what you've just written here, you have established that your base case puts node N in the traversal list.
Yeah, so then you just, it's not part of the, yeah, it wouldn't be part of the base case, because the base case is just
it's the clean slate of the world. It's what you start with. What are the assumptions that you're starting with?
Yeah, the assumption at the start is that you're gonna find a node that belongs to the list.
Okay. Yeah. So right now, so then you just told me that this traversal would represent the path, right?
Right.
So what has to happen in order to make that true?
That needs to be the very first thing that you add or do in the function, is add that value to the list of the traversals.
Okay.
Yeah, so then we don't even do any of that. We say just add the path, add the current node value to the list, to the choose traversal list. So that's the very first thing that needs to happen. And then so now I need to think about where is it going to happen, where you determine. Oh, that still happens in the base case because you want to get to the end of the. Yeah, I was thinking like where do you add that traversal list with containing the path to like that path grouping that you're trying to fulfill. It would still just happen at the end of the line when you hit the leaf.
Okay.
All right, so let me get rid of these. So you go to the left node, you add it to the current list, then you go to the left node. And then that gets added to the list. So you go 3, add it to the list. Left node 5, add it to the list. Left node 6, add it to the list. Left node, it's null. So then that needs to be if traversal path list contains a target. Now the question becomes, if one of the nodes is 3 though, that won't work. So
okay, I'm going to cut you off because at this point you are floundering. You have no idea what you're doing. There's no point in watching you continue.
Okay.
So I'm going to stop the timer. Tell me what your thoughts are.
Jesus. Yep. That sums it up.
Did you expect to do basically like like this? In terms of performance, was this performance on par with your expectations?
Pretty much.
Well, so which means that all the time that you've been practicing, you haven't really, like, to me, this says that there is no difference between what we did last week and what we did this week. And yeah, literally, there's no difference to me. So my question to you now is, how have you been practicing?
I've just been doing leak code problems that are in the like realm of what I'm trying to learn, which is this.
Okay, do you think back when you solve the problems on how you do it faster or what insights you needed? Because I'm gonna guess no.
I think when I do the leak code problems, I can just what I end up doing is just writing out the code so I can like lay out my thoughts in that way, and then it just makes more sense to me like that.
Okay, so then let me give you that shot. I want to see if you can write this out with code and get the right answer. You only get one shot at this.
I mean, at this point, I think I'm so far like in the weeds on this that I'm not going to be thinking about it clearly, and I don't think I'll end up doing it correctly on the first try.
Okay. I'm really trying to see like where I can help you, because I believe the problem is actually in your practice. Like I like a lot of the stuff that you're talking about should have been fixed when you started thinking about like how you do the problem faster. Like passing in the node when you talk about base case, a lot of my notes here basically revolve around you not even really understanding what base case is. It sounds like you're just throwing that terminology around without actually truly understanding what it means. So, going back to the practice before I give you the feedback. When you do a problem, how often do you get it on the first try?
Other than like minor syntax errors, I'd say maybe like 50-50.
Why 50-50? When you don't get it, what is it usually the other time?
It's usually an edge case that I didn't consider.
How long do you spend on these problems, and how much time do you spend on reflecting on them and how you do them better?
I probably spend like an hour to an hour and a half, and I don't think I really reflect on them too much. Maybe like 5 minutes, 10 minutes.
There we go. So when you do a problem and you reflect back on it, whether you could solve it or not, well, let's take a problem that you can't solve. Like this one. What is the reasoning? What would you say your if you were in this position and you want to do better, what would you be looking for?
So what would I be looking for in terms of
improvement? Like, give me an example of a problem that you did that you didn't do well on. Like, it took you an hour to do, and then you thought back on it, what you could have done better, and what was the conclusion that you came up with, and why.
Let me take a look at my list here.
Yeah, and if you could share that, that'd be really good.
Here, I just did this problem like before the stream.
Okay.
Let me paste it in. I think you'll know this. This is Jump Game.
Okay.
So I wrote out my notes in the comment below the code before I started coding.
Okay.
And then I started the coding.
Okay. Do you have the doc?
I just pasted it below.
I'll paste it below. Okay. Let's see. All right. So going to take recursive backtracking approach. Each recurrence, I would try the current number of I. Okay. Let me actually pull up the jump path problem. Give me a sec.
Yeah, it's number 55. And this solution actually only worked in 74 out of the 75 test cases. It doesn't work in very large.
Okay. Given an array of non-negative integers, you are positioned at the first index of the array. Each element in the array represents your maximum jump at that position. Determine you're able to reach the last index. Okay. Okay. And then let's see.
But the other thing too that I'll add is like some of this stuff, like this condition right here, like I didn't write it completely correct the first time. Like I was planning on doing like a nullable boolean where it would be null, true, or false depending on like what the state was, and then I figured out as I was like writing out more of it that I could just be like, oh, it can just be default false, and then I'll just set it true if I find the path.
Okay. I mean, I think
so
this is fine. Basically, until we get to the last element of the array, we can jump. Okay, that's fine. I think, based on what I'm reading here, this is a little bit of a misunderstanding what base case is. Yeah. But their base case here is whether or not you have hit the end, or you're out of bounds, or you're not. That's really it. And if you're not out of bounds, then you will. If I understand what your code is doing, it's going to try to jump forward as like for every other cell. So for instance, if I'm looking at the problem right now, I see 2, 3, 1, 1, 4. You're going to go to 2, and then you're going to try jumping from 3 and 1 because those are the 2 elements that are reachable from the first cell.
Yeah, it's always going to try to jump the farthest it can at each cell first before it tries a smaller number.
Yeah, so it's going to try every permutation and combination. All right, I get it. Okay, that's fine. So yeah, I mean, you get the Okay, I think this is fine. How long did it take for you to do this one?
About an hour, maybe.
Why so long?
I think part of it too is just like I get distracted and I'm not paying like full attention to the problem when I'm doing it.
Yeah, because this should be like a 20-minute problem. The fact that it took you, okay, so when you thought about it, it took you way too long to solve it. What was the insight that you had to have before you when you looked back on it on how you could do it faster and better?
So I didn't recognize how I could do it faster or better until I looked at the solution after I submitted this one and saw that it was too slow on one of the test cases.
Okay, so then now that you saw a solution, my question now is, okay, what did you have to do in order for you to realize in order to get from where you currently are to the optimal solution?
So the optimal solution is like some greedy approach that I was trying to understand how it was working before this, and I hadn't figured it out yet.
Okay. How about one that you did figure out?
Let me see if I can find one.
Because I want an example of one where you really took the time to analyze and understand why you made the mistakes that you did and what you could have done better. I want to see one like that. Because what this is looking like to me is that you are spamming the LeetCode machine and saying, "Oh, I'll do better next time." That's basically what the vibes I'm getting right now.
Trying to figure out which one of these is related. Why does that even have a solution if I don't make? Does it need to be recursion? Because I'm trying to find one that's recursion.
Okay, so you didn't even practice recursion this entire week.
I'm pretty sure I did. Like, I was doing like a couple of DP ones and stuff that were recursion based.
Okay. How about one that wasn't DP?
Did I not practice recursion? Am I going crazy? I swear I practiced recursion.
Because, I mean, if you didn't, then that would explain a lot.
Why do I think I practiced recursion if I didn't, though?
Well, I don't know.
Okay, here is one.
Okay.
This is validate binary search tree. I don't remember if I even did this week or if it was before, though.
Okay. Alright, validate tree. Alright, fine. This okay, so check left case base cases if node is null, return balance balanced. You're checking to see if a binary search tree is balanced, right?
Given the root determines valid binary search tree. If it's valid, so like if the nodes on either side are the correct values.
You mean like height balanced?
No, just like because so nodes lower than the root have to go left, nodes higher than the root have to go right. So you're just checking like the
Oh, can you link me to the problem then?
Yeah, here.
Did you paste in the doc? Okay, good, cool.
Yeah.
Validate binary search tree. Cool. All right, let's see. Determine if it's a valid binary search tree. Okay, just see if the node. Okay, I see. You're just making sure to see if the nodes to the left of it are smaller than the root and the right is bigger. Okay, fine. Makes sense. And this is how you did it?
Yes.
Did no pseudocode or anything?
Whatever's down below.
Okay.
So.
Sure. So returns left subtree good, left value is good, and right value is good. Okay. Left value is good. If check is not, if it's null, node value, check right. What's the value of check right?
Check right is.
Oh, it's the return. It's your return. Okay.
Yep.
So check right one, whether or not you found the node value. Okay. So you want to check the right-hand side and see if the node is less than whatever you found on the right-hand side. You want to check the left to see if left is greater than whatever's on the left-hand side. Otherwise, return true, fine. Check right, check left. Okay, you need to see if it's within bounds. Sure. Check right equals... Okay, I see. You did it from the bottom up. I got it. Okay. How long did it I think that's okay. So what is the... How long did it take for you to do this problem?
Maybe I don't remember, but probably looking at it, probably like an hour to an hour and a half.
Yeah, that's way too long. Why did it take you an hour and a half?
I'm probably because of the same thing that happened last time, which is trying to figure out how to return all the stuff that I need in order to determine, do the comparison.
Yeah. Okay. I'm starting to see what your problem is. Basically, you don't have a good eye for really evaluating your own mistakes. I think that's okay. But then there's also, I would say that the process that you take to do this is like you thrash. I'm going to say you basically thrash until you get the problem, and then because you thrash so much, you're not able to remember the steps that you took to get there. So I feel like a lot of what you do in order to try to improve isn't really understanding what insights and techniques that you needed. Rather, you just tried memorizing the answer. I think that's more or less what you're doing here. This is basically my intuition. So with that, let me share with you my notes, and then let me see if I can turn this into something a little bit more helpful. So first, I'm going to just put it over the jump path stuff. So first of all, I don't understand why you did stack trace to begin with. You haven't told me what the idea is. You are, I don't know. Like, stack trace is meant to record values, and then just like be able to follow what your logic is doing step by step. But you haven't presented me with any kind of pseudocode or logic that you're planning on doing. So I don't know why you're doing this.
Okay,
So
I was doing it in the beginning because I had like no idea how to solve it, and I wanted to see if I could identify a pattern.
Okay, but then you should be able to do this without having to do a stack trace. You could just do it in your head. I think this is the one time I would say do it in your head because it's so much faster when you're just fleshing out the idea and you're not really sure what exactly it is. So you don't have to write it down. So good check on the common ancestor at around 352. It's like, oh yeah, what happens if, this is when you said, oh yeah, what happens if one of the nodes is the ancestor. Okay. And then you mentioned like, and then this is where I think after that you kind of start falling apart actually. So you start talking about the recursive case, and base case, and I'm like, remember how I said, hey, what problem are you exactly solving? The thing is that, you remember how like the recursive relationship is Tn equals like Tn n minus 1 plus order operation on n or something like that? Do you remember this notation from math?
No.
So basically, a recursive relationship is defined as the doing an operation on a smaller case, and then doing some operation on the current case. So in other words, let's say I did a summation, right? So if I had the 1 plus 2 plus 3 plus 4 plus the Fibonacci numbers, right?
Right.
The Fibonacci number at 4 would equals the Fibonacci at 3 plus the U4. Why is that? Because the Fibonacci sequence for 3 is just 3 plus 2 plus 1. Right? This is what t equals 3 is equal to, right?
I thought it was 3 equals 2 plus 1.
Does this look familiar now? Does it make sense? Because the Fibonacci sequence of 3 is 3 plus 2 plus 1, right? The Fibonacci sequence
I thought this Fibonacci sequence of 3 was just 2 plus 1.
Okay, okay, sure, whatever. Whatever. Then let's go by that. I don't remember exactly the Fibonacci sequence either. But you get my point here. That, let's say the Fibonacci sequence of 3 is 2 plus 1, right? Fibonacci sequence is 4 is 3 plus 2 plus 1. This
Yep.
right here is equivalent.
Or no, it would just be 3 plus 2.
Okay, wait. Okay, maybe I'm confusing. Okay, whatever. I'm just trying to illustrate the idea here. Let's just assume that. Okay, let's not call it Fibonacci. Let's call it summation. Let's call it summation, right?
Okay.
So let's just say summation of 3 is 3 plus 2 plus 1, right? All the numbers that come before it.
Yep.
Okay. Well, now let's say T4. T4 equals 3 plus T of 3 plus 4, which is equal to 4 plus 3 plus 2 plus 1.
Yep.
So why does this work? Because this is the recurrence relationship. It means that if I can handle the state at 3 and then add 4 to it, then I can handle the state at 4. Does it make sense?
Yeah.
This is what recursion is. Fundamentally, it's like, hey, for this particular state, if I can throw my recursive function at it and it will handle it for me, then I just apply my current state onto it. Then I have just done the function for my current state. It means I'm relying on solving the previous state. So, what the heck does this have to do with what the hell I'm doing? What I'm talking about, right? Well, when you talk about the recursive case for iteration, I don't know what kind of problem you're solving because you haven't told me what this state is and what the evaluation is. So in this case, remember how t of n is just, in here, t of n is just n plus n minus 1 plus n minus 2, At least I know that you're solving this problem. And you've already defined this recurrence. This right here, you haven't told me what the heck problem you're solving. You told me like you're trying to do like some traversal. This is basically what I assume that you're doing at this point, because like, wait a minute, you're not solving the LCA problem. You haven't told me what function you're using to solve it, so there's no recursive case. The only thing I can think of is that you're trying to get to a point where you say, hey, I want to traverse through the tree, and then after the full traversal, I get some result, and then I evaluate the result. This is like, at this point, when you're saying the recursive case, this is the only solution that I can think of that you're going to go for. This tells me two things. The first one is that you're not comfortable with traversing things, with doing an evaluation while traversing. You're comfortable with separating a traversal and then evaluating the result, which is fine as a naive solution. But this is not necessarily recursion. You're literally just doing a traversal plus an evaluation. This is not recursion. So that was my thought right there. So you were just like kind of throwing out terminology and not thinking about the entire problem. So you decide that, okay, well, let's return the path. And you basically follow what I predict. You are eventually get to a point where you are basically saying, hey, I want to traverse through the tree, find the paths to the nodes, and then evaluate the paths, which is pretty much what this here led you to do. So that's fine. That's fine. Again, that's fine as a naive solution. But then you should have. But that's the first thing that you should have said. You should have said, "Hey, I want to traverse through the tree, find the paths to the nodes, and then evaluate the paths." That was the first thing that should have been coming out of your mouth. Instead, you were throwing out recursion, recursive case, and a bunch of other shit. And I'm like, I have no idea what you're talking about. If you just start off, yeah, you did exactly.
I was gonna say I didn't know I wanted the paths to the nodes until later, so that's why I didn't say it.
Yeah, so basically you spent basically 9 minutes just kind of like talking, and I feel like you could have just come up with this one on the fly. Actually, you should have instantly recognized this in 3 minutes. You should recognize that was your naive solution. Like this is like, if you understood exactly what you want, like you could have played around with it, traversing through the tree, and then you realize that, hey, I can collect the nodes and then evaluate the paths. That should have been like 3 to 5 minutes right there. Instead, it takes you like almost like 9 minutes. 9 minutes to do it. So that's like way too slow. So this first thing, what this first tells me is that, hey, you do not understand what you yourself want in these problems. Like a lot of these recursion problems boil down to like only a handful of things. They boil down to like whether or not you can do DFS or BFS, and whether or not you can, or you can optimize on a naive solution like this. Those are the only two things. If you do enough recursion problems and you think about the pattern, then it really becomes really simple. Most like tree problems boil down to this. It just boils down to do something on the left, and then operation on current node. Do something on the right. That's basically what it boils down to, you know. And do some, or you can flip these around, and instead of doing current operation on the node, you could just, current operation on node plus x plus y. Literally, it's just some permutation of these 3 steps. That's what almost every single binary tree problem comes into. So, yeah, that's basically what this is. And to me, what you are doing here already screams you do not understand this pattern already. You don't really understand the nature of recursion, at least when it comes to trees. So that's basically it from that point on. That's why you only gave up on a minute of thinking. It's like, because you didn't understand this. You didn't understand, hey, how do I basically evaluate while recursing? Because if you really think about it, you don't need to go through every single path. I mean, you don't have to go through every single path. You don't have to repeat nodes, because in its essence, when you look at something like, let's say our nodes was like 1, 2, 3, and 1, 2, 4, right? Let's say that these were our paths, for instance. 1, 2 should have been like, oh, hey, this is redundant. Why don't I just evaluate it at 2? What does it take to evaluate at node 2? And then from there on, that should have been your cue to basically realize, hey, wait a minute, I can do this while recursing. And that's why you didn't think of it. Because a lot of times, there's a lot of problems out there that basically go from a naive solution to an optimal solution that basically start off with, hey, traversing and then evaluating paths, or evaluating some common thing that is constantly being redone. There's an inefficiency there that should have clued you in that, hey, this is probably the way to go. So you didn't have that. That's why it didn't recur to you. You never really thought of a problem like that. So, and so basically from there on, I would say, the naive solution should have taken you like 10 minutes to do. But then I started realizing that you're like skipping steps, you're slapping on code ideas. You didn't understand your base case or recursive case at all. So in other words, you did not understand, at least the way I see it, you didn't even understand how to do a traversal. That's basically what this tells me. You didn't know how to do a traversal.
No, I know how to do a traversal.
Then why was it so hard up here?
Because I was trying to figure out how to evaluate at the same time.
Yeah. But the thing is that you should have immediately slapped on the traversal right lickety split. But then it's like you start doing the operation and adding these nodes while you're traversing. Okay, I get your point. I get your point. What you're trying to say. You're trying to say that, hey, I can write a DFS. I can write in order, pre-order, post-order, traversal. Fine, but that's not, anyone can do that. It's like you need to be able to create these paths. That's also really simple, you know, because all it is just pushing a node onto the list and then popping it off once you're done evaluating. So this is basically my feedback to you right now is that you really need to spend the time to identify common patterns between a lot of these recursive problems, and really reflect back on what does it take, why am I spending so long on doing these problems, etc., etc. And with 10 days out, the best thing I can do for you is actually literally just tell you how to think about these things. So let me pull up my iPad. Give me a sec. Okay, looks like it has to charge. God damn it. Okay, so let me just type it out then. So literally, so suppose I have A, B, C, right? You follow me so far?
Yep.
Whatever operation I do on C needs to be able to be done on A and B, right? I don't care if A and B have children of their own. I'm coming into this state with some inputs. Those can be like a list. Those can be like, I don't know, a variable, etc. Like integer, whatever. It doesn't matter. This is the state of the world that I started. I don't care if A and B have children of their own. They're nodes. They are nodes. Or null. Something, right? Now, if I do an operation... Now, what we're trying to do is figure out an operation on A. Figure out an operation on... Sorry. Operation on C. Such that it can be applied to A and B. And, of course, this operation needs to have inputs and outputs. So, in other words, when I'm doing this, I need to figure out what the heck my function needs to return to me. So, in other words, let's actually solve this problem. Given a binary tree, find the lowest common ancestor of two given nodes. Let me just do the problem for you. So basically, when I see this, I think, okay, well, I need to find the nodes, right? So the nodes can either be the nodes can be either one in left subtree, one in right subtree. In which case, C is the lowest common ancestor, right? Both of them can be in one of the subtrees. In which case, I need the node. The node is in that subtree. And I can return it, or, you know, record it. Right? Or it's in neither. It is in neither. In which case, the current node is not the lowest common ancestor and is not in any of the subtrees. I would argue that I have figured out every single possible scenario here. Right? Hello?
Oh, sorry, I was thinking about it.
Okay. I mean, I could say also that if one in left subtree and not, or say one in one subtree and not the other, then I need to be able to pass back some, let's say, value indicating that it is found in that particular subtree.
Right.
So I would say, like, I've pretty much covered every single permutation with this, right?
Yeah.
Yeah. So this is basically what I'm starting with. So how does that play in? So which means that I know that I need to return back a node because based on this, I'm required to find some kind of information here. I'm also required that the node is in that subtree and I can return it. So this requires that I return back a node. This requires I turn back a node. The current node is not lowest common ancestor, is not in kind of the subtree, so this could be like a null or a false to indicate that I did not find it at all. Or one is in one subtree and not the other, pass back some value indicating that it is found in that particular subtree. So I could return back let's say I would say, let's say true. True to indicate that it was found. So what does this mean? That means that these are my outputs to the function. It means I'm going to need to return back a node and a true false. But then what does my code take in? Well, my code needs to take in the current node that I'm evaluating, of course. And then I also need to find out, based on that, I would say that's pretty much it, I think. So I know that I'm going to get put in a node, and that I am going to get back out a pair of Boolean and a node. So I identify what each of my functions does. So what does each of these Boolean and node do? So node is going to be, so based on what I've just described, node is going to be the lowest common ancestor found. Boolean is whether or not a node is found in that subtree. So it could be one node, it could be two nodes. Node or both is found in that subtree. So my evaluation is always going to be if in that pair, so let's say if pair.node exists, then I have found the lowest common ancestor. Otherwise, evaluate pair.boolean to see if I've found at least one of the nodes. Now, at this point, this is what I'm going to ask. Hey, wait a minute. Are these nodes going to be different or the same? Because if I find the exact same node, then I could end up inadvertently fucking myself, probably. So at this point, now that I understand what my input and outputs are, I need to start looking for my blind spots. So my blind spot would be, okay, well, what happens if the current node is one of the nodes? Or are the nodes guaranteed to be different? What then? Okay, well then my condition changes a little bit, right? So let's take the first one. Whether the current nodes is one of the nodes. Then I just need to have it, then only need to look for the other one. So this means that I can evaluate this one first. I can evaluate the current node I'm looking at first. Are the other nodes guaranteed to be different? Let's just say for the sake of simplicity, yes. Just to make our lives easier. So for now, what is my algorithm? So I have all the pieces I need. I know exactly what I need to do. And I know approximately what I need to return. So my algorithm is going to look like this. So function node n. So then I'm going to evaluate. I need to pass it. I need to also know what my node x, node y are as well, because this is fundamentally what the function is going to be doing. I think I left that out. So I should probably put that back in the input, but you kind of get the idea. So then I know that that I need to make sure that it's one of the nodes equals to the node. Sure. So let's start with node x. If I need to find at least one, I just need to find at least one of them, right? So then let's say left pair equals to node n x y, n dot left x y, and then right pair, right? Of course, this is like the recursive case. I'm getting a little bit ahead of myself, so let me slow myself down. The base case is if n equals null. What happens if n is equal to null? What should I say if I found these nodes? Well, then I would argue that my pair did not find a node, did not find the lowest common ancestor. So I'm going to return back false and null. So I didn't find the lowest common ancestor, and I found neither of the nodes. Okay, so at this point, I know my n is not null. So which means that I am free to try and find the left pair and the right pair, right? So, the left pair. It's like, this means that did I find a LCA in the left? And based on what I just said, that I need to I'm going to return back a Boolean whether or not a node was found in that subtree or the lowest common ancestor is found. But I said that I wanted to take the pair.node as precedent up here, right? So which means that if left pair dot node does not equal null, return left pair dot node. And I'm going to do the same thing on the right side, right? Return right pair dot node. Okay, well that means that at this point, that means that I did not find a lowest common ancestor at either of these points. Now that means that I could have maybe found one or the other in each, you know? And so in which case, if left pair dot boolean, let's say boolean, and right pair dot boolean, if I found a node in the left side and the right side, then I'll just return back the node. Okay, well, let's say that at this point now it's either or. It must be either or neither. So let's handle the either or case. So if left pair dot boolean, which means that I found a pair in the left, but I did not find it in the right, because again, this up here precludes me from that. Let me turn off the bold. Then I need to be able to return back a pair that says, hey, well, I did find one of the nodes, so let's return back true, and that I did not find a lowest common ancestor, but I at least found one of the nodes in the subtree. So if I found it in the left subtree, I found it in the subtree containing n. And then same thing here. It must be in one of the other. So by that logic, I just do the same thing here. Right side, return true null. Otherwise, return false null. This is basically the way I would do the problem. Again, I could probably clean this up and somehow encode both the Boolean and the node together. But as you see, understand how my logic works, right?
No, I think I got lost, and I'm trying to figure out exactly what's happening still.
Okay, where did you get lost?
With the pairing of the Boolean and the node.
Can you highlight the line?
So like when you do, like just like the whole concept of returning the Boolean with the node, I guess.
Okay, so I defined up here that the pair.nodes exist. If that node exists, I have found the lowest common ancestor, right? This is what I've defined for myself.
If the node exists, how do you know it? So the lowest common ancestor is the node itself that you found.
Correct. So in this pair, this node represents the lowest common ancestor if it was found. Otherwise, it's going to be null. I have already set myself up. I've already said that this is what I've defined the output to be.
So do you basically, so like you pass, so basically you say the lowest node is the lowest common ancestor, and then you pass that up until...
No. I say if I have found the answer to our overall problem, that is going to be a not null value. If I have not found the answer, that is going to be null.
So I don't know how you can say that you found the lowest common ancestor if you've only found one node.
Yeah, I'm not. I did not find the answer. That's why it's null.
Okay.
Remember, I said, let me repeat myself. If that value is not null, that must be the answer. If
Right.
that value is null, I did not find the answer.
Okay.
That's what I've set up here. If that node exists, then I have found the lowest common ancestor. I have literally defined that as the output of this function. So, does this make sense?
Yep.
Okay. But you understand, like, I literally just said, hey, what are my inputs? What are my outputs? What am I expecting? That's literally it. I just logicked the entire problem. I did not have to do anything fancy. Do you understand what the difference is between what you did and what I did?
Yeah, but I don't know how I would ever get to this point if I wouldn't come up with it even to begin with.
Yeah, that's also the problem as well. So let's actually go from your naive solution and then see how we might come up with this. I just want to show you that this is the answer. So let's actually look at your thing. So you said that you want to... that you had a list of paths, right? You had a list of paths, or list of lists.
Yeah,
Okay, sorry, let me respond to someone in chat, my bad. So Nicholas, you asked, why check if the left code does not equal null? Because I have defined for myself that if I have found this, if I found the answer to our entire problem and I found the lowest common ancestor in a subtree, that I would return it. So by definition, by the result definition, by my function definition, I'll go to other questions later, but that's basically the gist. Yeah, so let's see how I can get to that answer from what you did. You said you had a list of nodes, essentially, of paths, right? And then what I would have realized is, hey, wait a minute, like I said before, let's say 3, 2, 1, you know, and then let's say 3, 2, 5. I would have realized, hey, wait a minute, I'm repeating these steps, and these represent, at this point in time, I was at this node, right? So that means that all I really have to do is do my evaluation when I have visited node 3, when I've visited node 2, and everything below that, and then pass that back up. So in this particular case, if I know that 2 is the lowest common ancestor, I can pass that back up to 3, and 3 doesn't have to do anything crazy. So this is like my first clue in like, hey, wait a minute, I can actually do this while traversing. That would be my, like, I am storing way too much information that is unnecessary here. Does that make sense?
Conceptually, yes, that makes sense.
Right, conceptually it makes sense. The question is how to execute on it. But as long as you understand the idea, the execution just comes from, you know, being able to actually write it out. And in which case, let's go back to your code and say that let me write out your pseudocode here. Do a traversal node n x y, and then say, hey, visit. Let's say, oh yeah, now I have my list, right? List of nodes, right? And then let's say call it a list. And so I would do list dot add node n, visit left, visit left, and then visit right, and then list.pop n. This would literally just be your, and then if n equals null, return. This is literally the traversal, right? Nothing fancy. So visit left, visit right, and within each one, I'm guaranteed to have popped and unpopped the list. So I've guaranteed that my list, when I exit this function, will be the exact same as when it went in, right?
Right.
And then let's say
point.
Now, don't worry, we're gonna get to the optimizations a little bit later.
No, I meant at what point do you add that to the paths if it contains the value you're looking for?
Good point. Let's actually think about this. So, in other words, I want to add in. This is probably where I would start. Let very absolute no optimizations. I would just literally ask global list.add list.clone. That's the very naive solution. Of course, then we start comparing every single node and blah, 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 blah. This doesn't really work. So, in other words, let's filter it out. If n equals to x or n equals to y, then I know, bam, presto, I have literally just added a list that must contain and terminate at one of my found nodes.
Right.
So, in other words, all I've done here is just, hey, I am adding this. At this point, I'm just adding my current node to the path that I've traveled thus far. That's all I'm doing, right?
Yeah.
Yeah, so I'm doing that, and then I add that list to the global list. And then the second part would be evaluation. So I know that if I found, this is probably where you would ask, hey, am I guaranteed that these two nodes are in the tree? Because if they're not, and I gave you some random ass node, then your function might break. Does that make sense? Because this is like an immediate consequence of, hey, you assume that these two nodes must exist in the tree. Not to mention, you also have to consider what happens if they're null.
Okay.
Like literally just because of the decision that you made here to evaluate two lists that I must, actually validate these assumptions. You assume, like, what is causing me to have two lists? Well, I need to be able to have two nodes that are distinguishable, right?
Yeah.
And then in order for these to actually generate paths. So based on that, that's just all logic. So then from here on, it would just be for n in lists, or list, what's it called, min, for n in 0 ... let's say min of length of, I'm switching over to my Python brain right now, I don't know why. Global list dot get at 0, global list dot get at 1. You get the idea. And then so if let's say value a equals to global list dot get at n. Actually, I should probably be a little bit clearer about this. Oops.
Yeah, so this evaluation is happening outside of the recursion, right?
Yep. It's after everything's said and done. So let's just say list 1, length of list 1, length of list 2. And then value A would just be list 1 dot get at n. Val B equals list 2 dot get at n. If A does not equal B, then return back whatever the previous value was. You know? And then I would just say the previous value equals to root, and then otherwise we'll just assign previous value equals to A. Something like this.
Yep.
This is basically what like I noticed here that all I did was just break it down into very simply a traversal, where I have just created a list that terminates in X and Y, and then I just did a comparison. This should have been very, very simple, and I think it only took like 10 minutes to do, something like that.
Yeah.
Yeah. So this is what I mean by it should have taken you like very easily 10 minutes, like 5 minutes to figure out, 10 minutes to write. But really, again, because the insight would have been, hey, wait a minute, I found out about these nodes. I realized that I'm doing a lot of repeated work here, that essentially me traversing over list 1 and list 2 is the same as traversing through those nodes themselves. Then I can just start combining the operations. So that would have been the insight. And I know I'm basically spending a lot of time talking about a lot of optimizations and things, because I really want to... What's the best way for me to describe this? I feel like your focus is it's very scattered on a bunch of different topics, and you don't spend a lot of time reflecting back on doing these problems in a more efficient manner. Like, you keep saying that it takes you an hour and a half to do the problems. Doesn't that strike you as a little slow?
Yeah, but I also get distracted and I'm not actively working on it for an hour and a half usually.
Well, that's also the problem as well. Like, I think we started to figure out the root cause of all this. It's that you're not dedicating, like, focusing on one time. You know, it's like you're just scattered. You're just like trying to chip away the problem, come back to it later, chip back, come back to it, and eventually you solve the problem. But the thing is that in a realistic setting, you're not gonna have that. You're not gonna be able to. You're not going to. Like, the interviewer's not going to say, yeah, sure, take an hour and a half break or whatever, and if you come back later. That's not how the interview works. It's 40 minutes of you hardcore going at it 5 times in a day.
Yep.
Does it make sense to practice like that? Doesn't it make sense to study like that?
Yeah.
So, really, here, I feel like I can't help you if this is the way you practice, because you need to focus on, like, drilling giga hard on the problem. And, you know, you need to be able to do the same type of problem over and over and over again, and be able to just drill in on why you didn't do the problem correctly, instead of like spending 5 minutes like, oh yeah, maybe this, maybe that. And it's like there are several logical, like, throughout this entire thing, I have not introduced any crazy kind of topic here that you haven't heard of. In fact, most of it is just logic. Like, being able to nail this logic is, like, super important. Like, and most of this logic just comes from, hey, I have seen and done this a million fucking times in the past, creating a list of the path that I've done so far and backtracking it. That's what this add and pop is. That's all it is. And then doing operations while traversing That's just comes from me doing the traversal plus evaluation a bunch of different times, and then realizing, hey, wait a minute, I keep making this mistake. And in order to transform from a traversal plus evaluation approach to just traversing and evaluating while traversing, I need to do this, which is essentially plan out all the cases that I will be evaluating at, and then defining what my function will do. That's the only difference between what you're doing and what I'm doing. The only difference is really just drilling down into the problems that I'm doing, repeating them over and over again, and realizing that I'm making a common mistake. So with 10 days left, it's very difficult for me to... give me a moment to think. I need to think of like a path for you forward. Because essentially, we haven't made... I would say, effectively, we have not made progress in the past 2 weeks if this has been how you have been practicing. And I mean, I can tell you what to do. But ultimately, what like 90% of this comes down to is the way you practice and treat your practice. And I'm really, really trying to think right now. Give me a sec. Like 10 days is not a lot of time. If I could get you to nail this recursion in 10 days, I feel like, and do it in the right way, I feel like that you could have like a 65-70% chance. Like, let me ask you, what are your thoughts? What do you want to do? What is your plan going forward?
Well, I mean, at this point, it's pretty hard not to have a defeatist attitude. Really, feels very negative. Not you telling me that I suck, because I know that I suck. That's the part I feel negative about. So I mean, I guess at this point, like, even if the answer is like it's fucking impossible, like I'd probably accept that. But then on the flip side, it's like, well, what the fuck did I just spend the last month and a half doing? I don't think that even answered the question you asked.
I'm really not trying to turn this into a negative. I'm really looking for the ray of hope here. Like, what do you think you are absolutely strong at right now that no one can take away from you? Like, when it comes to the interview, what is your strength?
For the technical interview, I don't know if there is one. Honestly, these questions I've never been good at. I'm trying to get better at them, but...
How long have you been studying for?
Call it a month. To be honest, sometime at the start of April.
Okay. And this entire time you've been studying like this, where you just kind of like chip away at it, and you know and then you just kind of come back to it and you get distracted again?
Yeah.
Okay. Is there a way that you can contact your recruiter to push this out like another 6 weeks?
Unlikely. I've already pushed it like as far as I think I can get it pushed.
Okay.
Honestly, I don't know if I have the mental fortitude left to do another 6 weeks.
Because most of your energy was basically, I'm not gonna lie, most of your energy was wasted. Like, because compared like to what you've done before at the very start of the month, you know, compared like to today, has there been a noticeable improvement at all?
Yeah, because I can at least now I know patterns and stuff that I didn't know before.
Okay, well, that's the bare minimum. We're not talking about patterns anymore. We're talking about being able to break down a problem. Patterns are just like, you know, I would say like optimizations on top of the actual thing.
Okay, well, I guess that's the problem, because grokking doesn't teach you how to break down a problem. It teaches you patterns.
Right, but I literally told you in the guide how to derive that. It's like, what are the common characteristics that lend itself to the pattern? Did you not read my guide?
I read the guide. I probably don't remember most of it because I forget when I did.
Okay. Let's figure out a way to salvage the situation. We're not here to complain. We're here to find answers. And my job here is to create that answer for you. Can you contact your recruiter and say that there's been a family emergency?
I mean, I can. Yeah, I can try that.
Okay, what I want you to do is, okay, if people are watching the chat, would you be willing to help him out? Just putting it out there. If someone is willing to lend their expertise and guidance to him, I think that would be really useful, because it's like, I can do it for sure. There's no problem that I could probably get you around if I literally screamed at you every day for like a month. But the thing is that that's not worth your time or my time either. And it's very difficult for me to turn this ship around without you having to practice properly. I think having a study buddy would definitely be the next best thing for you. That way they can like watch you study and make sure that you're actually thinking about the right thing and keep you on track. Because it's like, Let's do this. Let's spend the next 30 minutes crafting out a study plan for you. Because I'm going to operate on the assumption that you can get this pushed. And because like, even if I told you, even if I made you do another problem, we would still run into the exact same issue. So let's actually create a study plan for you. And let's see if we can, and I want you to contact me as soon as possible when you hear back from the recruiter. Okay?
Okay, man, she's gonna hate me.
It doesn't matter if she hates you or not. I can always send you another recruiter's name.
Okay.
But the thing is that we're really trying to give you the best shot here. And like, what was the reason that you gave before?
So originally it was supposed to be like this upcoming Monday or something, and then I said like, can we push it one more week so I can make sure I'm like super prepared and like have the best chance that I can. And then on top of that, I made the stupid idea of listening to other people and asking her to switch the already scheduled on-site from JavaScript to C#, creating extra work for her in that regard. So that's why I think she probably already doesn't have much leeway for me. I can hear the face palming through the microphone.
Yeah, I'm trying to think. Again, like, people contact me to try, and as a last resort, I'm gonna do my best to make it do the best I can. Okay. Sorry.
Yeah, at the start of this, I remember you told me people usually contact you as a last resort, and I wasn't there yet, but I think we're here now.
Okay, we're at the last resort. Time to see if I can pull a rabbit out of the hat. Okay, let's go ahead and let's pull that rabbit out of the hat. Okay. I'm going to share with you the doc. And for now, let's operate on the assumption that you can push this out another month.
Okay, and if not, then this will just apply to the next job I apply to.
Something like that, yeah. So basically your primary weaknesses right now, let's say let's go in order, and then we'll figure out the schedule later. So right now, big one is going to be recursion, essentially. And DFS binary trees. This one, I don't care what you do. I don't care if you get to dynamic programming. I don't care. I want you to be able to do this topic. So let's target date. Let's eliminate target dates. I really want you to be able to drill on this. Drill on this only. Just keep looking at problems and do the same problem over and over again. I literally want you to do like the same problem over and over again until you get fast.
That's one thing I didn't understand from your guide, was doing the same problem over and over again, because like I just remember how I did it last time.
Mm-hmm. Yeah, I understand this, but the thing is that I want you to logic it. Right? I want you to logic the problem. prove it to a 5-year-old. Notice like how when I did the problem and I talked about it to you, that I literally said it and proved it in a way that would literally anyone who didn't understand coding could understand.
Yep.
I want you to do that for every single one of your problems. I want you to logic it, prove it to a 5-year-old, no code. Literally, you should not write code for this, ever. I want you to be able to drive the logic for the problem, and then when you've written it down, that make sure that you can understand the path that you took. The path that you took to get there. What were the missteps? What were the mistakes? And what do you need to see to avoid these mistakes again? That's all I really want you to work on. Just the mistakes that you're making and how do you avoid them again. Okay?
Okay.
And then, do you have a full-time job right now, or how much time can you dedicate to this?
I do, but I can probably, like, don't tell anyone slack on a few days at work.
Yeah, I just, like, 1 week slack a little bit. It's not gonna kill you. It's not gonna kill your perf.
I'm blocked waiting on Infra to get back to be on a ticket anyway, so I can use that as an excuse.
All right. So let's look at the daily schedule. You're PST, right?
Yeah.
Okay. What time do you go to bed?
12:30.
12:30. Okay.
Wake up at 7:30.
12:30 to 7:30. All right. So we're gonna say this blue is your sleep. You're gonna get like 30. I'm gonna give you 30 minutes for lunch. Do you eat breakfast?
Yeah, but it's usually like pretty small, like on a go type of thing, like a yogurt, cheese. It's pretty
breakfast, brush your teeth, shower, 30 minutes in the morning. Giving you that. 8 a.m. sharp wake up. 8:30 to 9:30, I assume is like your check-in time with work, stand-ups, whatever.
Yeah, okay, so no gym. I usually go to the gym 3 times a week. So no gym next week, I'm guessing.
I don't want to disrupt your schedule too much, but I think at this point we got to pull out the stops. So,
yeah,
no gym.
Okay, so that opens up 7:30 to 9 because I'm like wake up and go straight to the gym. So 7:30 to 9 is open.
Okay.
Then like
I'm giving you 30 minutes for dinner. Okay.
10 to 11. 10 to 10:30 is like work.
Okay.
Because that's like stand up, check in, whatnot.
Sure.
There's probably 1 to 2 hours throughout the day that I have to do more like work meetings and stuff. Just call it like 1 to 3.
Okay. Okay, and the rest you can do.
Yeah.
Okay, I'm gonna say lunch at 12:30, 1 to, and you said 1 to. Sorry, you said 1 o'clock to 3 o'clock?
Yeah, 1 to 3, like, that's usually when we do, like, sprint planning and backlog refinement and stuff. I have to be at those.
Okay. Okay. Alright, so I'm going to basically do this. So these empty times are going to be your breaks. Break, dinner, whatever you want. And I mean, you need to start taking take this like very, very seriously. When I say 30-minute break, most of this break is literally just going to be you not surfing the internet. Literally need you not do that. I literally need you to treat this as if you're actually training. Like literally, like your life depends on this. No distractions. No surfing the web. No playing video games. No nothing. I need you to spend each one of these blocks.
Okay, I'm going to download a different browser that doesn't have all my tabs open, so I'm not tempted to click on other tabs.
Sure, whatever you need to do is tonight. That's fine. So again, I want each time you do a problem, you're going to do these 3 things very simply. 1, look back at the steps you took. Did you make any mistakes that led to inefficiencies or wrong ideas? 2, how do you put yourself in a position to not make these mistakes? So for instance, if you thought, like for instance, let's use your iteration thing for instance, right? You decided to, hey, I'm going to meander around for 10 minutes and then come up with a solid idea. What should have happened is, hey, the very easy idea is, well, I could just throw an iteration at the problem and then evaluate the result. The difference here is that you spent 10 minutes trying random ideas instead of going for the, the obvious and naive solution. So that is going to, so then now you know in the future, just try the obvious and naive solution and then see if you can use that as a launching pad. Do you understand how like you look back at that and you can use that as a helping guide to make your process a little bit more efficient?
Yeah, I think it took me 10 minutes to even get to the naive solution on that problem you gave, though.
Exactly. You need to be able to get there in 5.
Okay.
So if you just think about the naive solution, what's the very, very naive way of doing things? What you have in your pocket is like the patterns, right? Just throw the pattern out there. Just throw the traversal out there. It's like, okay, I traverse things. What do I expect to go in? What do I expect to come out from the traversal? It's like, okay, well, if I do a traversal, I can generate all the paths, and from generating all the paths, I can compare all the paths. That would be like the optimal naive solution. But then you need to be able to think that. So, second, put yourself in a position not to make these mistakes. You need to look back, say, hey, because I thought this happened. Because I decided to go down this route, this happened. Or maybe I could have skipped all these different steps, all this meandering, had I just done X. Right? And 3, what is the difference between the optimal solution and my solution, and what steps do I have to do in the future to get there? That's it. I want you to ask these 3 questions, and for every single problem you do, I want you to do a write-up. I don't care, like, because reflecting on your mistakes is almost as important, if not more, than making them. Because you can spend an hour and a half throwing yourself at a problem, and then just be like, 5 minutes, like, yeah, maybe this, maybe that, move on. But the thing is that you're just gonna make the same mistakes again. So instead, what I want you to do is like allocate more time to the reflection. So after that, what I want you to do is, are you okay with just like checking in like sometime throughout the week?
Sure.
I want you to, whenever you finish like 10 problems, notify me on email. I will look at that doc of the write-up. Make sure you show your work on that as well. And I'll comment on it. I'm gonna give you like the daily evaluation. Whenever you finish like 10 problems, or like you feel like you're kind of like, hey, I'm not seeing where my mistakes are, I keep making this mistake, send it to me, let me know. I will let you know what the problem is. Okay. And just keep doing this for DFS, recursion, BFS. And I think once we do that, we can probably get to somewhere in like, how many hours did we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 blocks. So we have basically about 10 to 11 hours a day. At your rate, that should be like, I'm gonna expect 6 problems. 6 to 9 problems. So basically, I should expect you like every day or every other day, you notify me, hey, I've done another 10 problems. I need your help. Okay?
Okay.
Literally, your whole life for the next however many days is literally going to revolve around just doing this, being very good at this. And do this again. Do the same problem until you basically know how to logic it, and then you don't make these same mistakes as you did before. And once you do that, carry it on to the next problem, and the next problem, and the next problem. So I'm going to send you one of the videos where I actually do this to myself. Yeah, this one's got like 41 minutes, but it should give you an idea of how to do things. 'Cause I imagine like after this session, you're gonna be pretty tired. So the rest of the night, just watch this.
Okay.
Like, notice how I would talk through my problem. I will like basically go through the logic of it, what I'm forced to do, and when I make a mistake, you'll see the mistake, and then I'll be discussing myself how the hell do I avoid this.
Okay.
And then if you have time, maybe watch this one too. I mean, these are also good problems for you to solve as well. And maybe you might want to do them along with me in those videos. But yeah, this is basically what I want you to do. Mostly focus on optimizing over your own mistakes, and avoiding them. So, do you think you could do that for me?
Yeah, I can watch those, and I'll try to do them along with you in the videos as well.
Okay. And so for the last 10 minutes, I want to go over like what that will look like if I was in your position on the problem that you just did. And for the people in the live stream who are talking about. Okay, so let's actually I'll discuss everything in the live stream and your guys' chat later. Let me try to help him out first. Yeah, so you do the track. So how comfortable are you with drawing stack trace? Seems like you're pretty good.
You're pretty comfortable.
Okay, great. So you have the tools on how to debug your solution. You have tools on how to detect it on pencil and paper without ever having to touch the keyboard. I would say you don't even need to use the LeetCode submission machine ever. So at this point, I am confident that you have practiced the tools on how to do it. All that's left is to execute on it in the right way. So let's actually look at the current thing that you did. Okay, so I see. Let's pretend rewind. I am in your shoes, right? And I say, hey, I'm given the lowest common ancestor. Okay, well, going back to all the feedback that Edward gave me, and let me bring it up on another screen up here. So, okay, so then, the first thing he said is like, why did I do the stack trace? Okay, well, I did the stack trace because I was trying to figure out my idea. So the first lesson I'm going to learn is, well, I don't need to do the stack trace at all right now. I only do the stack trace when I have an idea, So this is like the first lesson. This is the way I would be thinking about my own problem and feedback. So this will be like the first lesson I would learn. Like, okay, wait, why did I do this? Oh, I didn't have an idea. And why did Edward tell me to do this? Because he said that I was wasting my time. So, okay, so I'm not going to do the stack trace right now until I have an idea or algorithm. Okay, the next feedback that Edward gave me. There's a good check on the common ancestor. Why did he say that was good? Because I identified a corner case. And why is that? And so, in other words, I want to be more careful about my corner cases, or at least be aware of what each of my problems or suggestions imply when it comes to the assumptions or premises of the problem. So, I would say watch the stream once it ends, as well. Like, go back to the timestamps of when I give each of these suggestions. Like, okay, next one. Recursive case. What problem are you solving? Why did he say that I wasn't solving the problem correctly? Well, I was saying base case. I wasn't sure what I was doing. So, in other words, I need to be able to narrow in on the problem that I am doing. So, focus on the main problem. And how does each step that I do lead to the problem being solved? So, this is like, okay, the next feedback. Throwing terminology and not thinking about the entire problem. Okay, this goes back to focus on the main problem. How does my iteration, I know I want to iterate, but how does what I'm thinking about and approaching, and how I'm approaching the problem, affect the end goal, which is to find the lowest common ancestor? And so basically, I just need to focus. So in other words, the lesson is to focus on my efforts and tying my efforts back into the main problem that I want to solve. So focus on the main problem again. Okay, he said a lot, and we go to 750. The logic is good. Trying to find the path to each node. What does it take to get the path to each node, and what would you do with it? Okay, so this is the same thing again. Looking at the problem, problem, I need to make it clear how each test or idea I try is going to lead me one more step towards the issue. You know? Towards solving the problem. Next thing. Okay, 908. He said, like, I should have said this he said, this is the idea I should have started with. Why are you starting with the details? You should have said this first. Okay, which means that, instead of do not dive into details yet. Start with a very simple idea that I can understand and a 5-year-old can understand without code. So this is the lesson I need to learn from this, right? It's like, okay, 13 minutes. Why the hell he wrote, hey, why the hell did I give up? I only spent 1 minute thinking. Like, why did I give up? What caused me to give up? I gave up because I didn't know where I was going. I didn't understand the transition between the naive traversal and the optimal ones, which means, but what it took to actually figure out that I needed to evaluate while traversing was looking for inefficiencies. Well, I need to look for inefficiencies in my naive solution. Okay, well, what was the inefficiency in this problem? This problem had the inefficiency of doing repeated work. It was like, okay, so that means in the future, repeated work is a red flag for better solutions. Right? Next thing. 18 minutes. You fundamentally misunderstand what base case and recursive case is. Okay, why did he say that I fundamentally misunderstand what base case and recursive case is? Well, because the base case and recursive case applies to a recursive problem. Did I define a recursive problem to begin with? Or recursive solution to begin with? Well, I mean, my traversal is technically recursive, right? The traversal is technically recursive. But this is probably not what he meant. I think he meant more by the LCA, like how does this all tie together? Because again, if I had just started with a very simple idea and just simply stated that this was a traversal and recursive traversal through the tree, and then I was evaluating it, then I would have not been in this situation, which means that I need to correctly identify recursion or a recursive solution to begin with. So this means that I need to brush up on recursion and what it really means. Just because a function calls itself, if a function calls itself, how do I identify base case, recursive case? Are there problems that have recursive solutions that I can analyze and copy their thinking? This is basically the next thing. And I would say, like, well, because this is maybe, that I would not focus too much on it, but this is like the way I would think about my own things. The next thing he wrote is skipping steps at 22:45. Well, he says I'm skipping steps. Why am I skipping steps? What details am I leaving out? Why am I skipping these steps to begin with? So need to watch the replay for that. It's like, oh, okay, well, if I'm skipping steps, then that probably means that I was just writing random code. I need to be more ordered and organized. Each step needs to be a logical step in the process. Okay. So it means I need more attention to detail, and I need to make sure that each step is logical. And I present the idea at 23:36, he said, I present the idea very well, but it should have only taken me like 10 minutes. Well, that's the thing. It should have taken me 10 minutes, but, why did it take me so long? Because I did all these inefficiencies up here. I got sidetracked. I was half-assing a lot of the efforts and slapping code on, which means that my initial logic was weak. Because if my initial logic was strong, I wouldn't be slapping on code or trying to patch and pray. I would be able to get to the actual solution. So this means that I need to I need to focus more on the initial planning. So you can see like how basically we went through all the feedback that I gave you. You need to be able to do the same thing for yourself. Will you identify inefficiencies that you did and then ask yourself, why did I make this problem? Why did I do this inefficiency?
Okay. Yeah.
Okay. So, I need to, any other questions that you got?
No, so I'll just, basically do this type of breakdown for every problem that I do, right?
Mm-hmm. Yeah. And basically you just need to be able to look back at your own, problem. You need to look back at what you're doing and, yeah, you need to just be able to walk through all this. And really understand, like, hey, because I made this mistake, but that mistake comes from a reason. So, yeah. Fortunately, someone in the chat has offered to be your study buddy. So, guys, if you want to help out Devin, ping him in the Discord. I'm sure he would love the help and the positive reinforcement. I see that you guys are showing a lot of love, and I really appreciate that. Of course, I'm like the tough guy here who is, really trying to focus on what works. But if you guys are, I appreciate the fact that you guys are giving positive reinforcement and encouragement. I think that that's really helpful and very useful. So so here, I'm going to copy the link to the Discord. So yeah, join the Discord, ping him on there, and lend your support, guys. I really appreciate that. But yeah, as for you, I want you to be able to just do this. I want you to do it with the schedule we had in mind. And I want you to report. I want you to send me an email every day or every other day telling me about your progress. If you run into some issues, let me know.
Okay. And I'm going to email the Google recruiter on Monday and tell them like I had to fly back home to where I'm from or something, and just yeah.
Yeah, you had COVID. You had some kind of emergency. I don't want you to necessarily lie. Just don't give any more details than you have to. Push out like by a month, and let's see if we can get you there. I think that if you do this right, 1 week might not be enough. Depends on how hardcore and how good you are at this. But 3 weeks might be good enough if you can do this right.
Yeah, it'll come down to
how focused. It's almost essentially how focused you are. I can give you all the support in the world, but it's up to you to execute on it in a very focused way.
Yeah, well, I mean, at this point, I can't not try my best. If you're trying to help me as best you can, I can't not try my best, or because then I'd just be making you waste your time, and I don't want to do it.
Okay. Yeah, you got plenty to think on. Take the rest of the night off. It's been hard for you. Watch the videos. Watch what I do. Try to copy the style that I present in. Copy the way I talk as like a template, and see if you can make it your own. And because I think I do a pretty good job at logicking the entire thing, and maybe spend tonight just like kind of watching, observing your own performance and how I explain things and do things. See if you can get inspiration from that. I don't want you to feel too bad over this. Again, it's a process. It's just that we just didn't have enough time. But we're gonna try we're gonna try giving ourselves as much time as possible. We're gonna try pulling a rabbit out of the hat, and we're gonna do our best here. Okay.
Yep.
All right. Anything else?
No, I mean, all I'll say is like we're getting to like very core life issues for me outside of just solving algorithm problems.
Well, I mean, like 89% of the things that you do in life, you're gonna do in one area, it's gonna happen in another area.
No, trust me, I know it does. I'm just saying it's now leaking into here, like not being able to pay attention to a problem for more than 10 minutes before getting distracted by something else, for example.
Yeah, but I mean, I didn't even try to hit that. But yeah, you notice how like it just kind of comes out, and I can almost always tell what kind of person a person is. That's why I think it's almost impossible to like basically lie to an interviewer or like misrepresent yourself. Like essentially, I can tell a lot of a person just by like the way they solve a problem in like 30 minutes. So that's the whole reason why I thought it'd be the interesting tidbit. But yeah, get yourself a drink, shower, cool off, reset for the night, and then try picking this up tomorrow.
Okay, I will do that.
All right, good luck, man. Ping me if you need anything.
All right, thanks.
All right, for sure. Take care.
See ya.
All right. Okay. So, I'll answer some of you guys' question in the chat. So, why do I check the left pair equals null? I think I answered this one. Basically, I've already defined for myself that the lowest common ancestor must be null, just based off the definition of the function. If it exists, if the next node is not null, then I found the lowest common ancestor. So otherwise, if it's null, then I did not find it. I recommend the weekly competitions. Okay, Ricky. I think you definitely should ping that to him. Any suggestions, any kind of positive encouragement that you guys can give him, I think he'll appreciate that a lot, because my job, the way I see it, I'm here to give the results. I'm here to tell him exactly what he needs to do. Positive reinforcement and the mental thing is like it's primary for sure, but people hire me to give them that skill to begin with. If they have the skill, they don't need the mentality necessarily. Of course, that the mentality does, it also does affect a big portion of your performance as well. And this is not something that I've been historically very good at. I'm in the business of getting results for people. And if it takes encouragement to get him there, then yeah. But at this point, I don't believe the encouragement is what's needed. I believe just drilling down on your hardcore habits and changing them is what's needed. And that's kind of the stance I take. I think the support itself, I'm definitely giving him the support as well by, saying, hey, ping me every day, email me what's going on, and just give me a 5-minute glimpse on your doc. I think that's the best thing I can do for him. 6 weeks is better than 6 months or 1 year cool off. I completely agree. Ricky did last minute push. Yeah. I think you, depending on the relationship that you have with the recruiter and how badly they want you, I think it's all possible. I just don't know the relationship with him and his recruiter, because he mentioned that he kept pushing the interview over and over and over again, and I think definitely that can leave some kind of bad taste. But at the end of the day, I don't want him to get into the cool off period. I mean, maybe 6 months to a year might be good enough for him to, start knocking out the bad habits. Maybe that's exactly what he needs. But again, my job is to try and make a miracle happen. And I'm going to do my best to do that. But otherwise, I don't think it's necessarily bad if he does a 6 months cool off. I think it'll give him plenty of time to really fix his habits, both in LeetCode and probably in engineering and life, to really focus on one thing. Because, these habits aren't changed in 10 days. These habits change because of daily practice over a long period of time. And if that's what's blocking him from doing well in the interviews, then better pay that price and use this moment as a learning process. Do you think I think he's mentally defeated? Maybe positive enforcement or that he can do this? Yeah, the thing is that when I do things, I don't just shout encouragements, because random encouragements are just oh, you could do it. Well, what exactly am I supposed to do? I literally just gave it my all, and I did what I believed was right, and it still didn't work. What the heck do I do? And then, at that point, I see it more as a torture. You're basically forcing him to do the same thing over and over again because you haven't given him any other options. And my job is to give him those options. So maybe positive reinforcement. Maybe I give a little bit of that at the end. Because, again, I'm doing what I believe in. I'm giving him what I believe is going to be his best option. And I'm giving him a path. I think that's much better than simply shouting random positive encouragements. And I think that if other people who are watching the stream give it to him and can empathize with him on some level, I think that's gonna be a huge difference. Because there's a power dynamic to this. Because if you hire me, then you're essentially acknowledging, hey, I need help. You're better than me. I need you to help me for this. So for me to just go out and say, hey, yeah, you're doing great, you're doing fine, it dilutes the value of what I'm trying to present here. If I do it just meaninglessly, there's no point in what I'm doing. It just means I'm just giving out random praise for nothing. And I see that I should only give out that praise honestly. That once I see the results in the person, that they're worthy of praise, then I give it to them. That's the dynamic that we have here. And I on some level, I do need to respect that as well. Don't get me wrong, I will encourage him if I believe that is what the push that he needs. I'll be his cheerleader if I believe that's the push that he needs to get results. But again, like I said before, that's not his problem at this point. I would really like to be able to pay for mentorship with this guy. Amazing mentorship. I mean, I don't really see myself as a mentor, to be honest. I'm just in the business of getting results, and whatever it takes to get there. Your explanation of recursion and deep diving program was very clear and easy to understand. Maybe this would be a great video idea for you. Yeah, I think I do that to some extent. I could definitely make a very short video on how I see recursion. I don't think that's necessarily bad. I haven't done a video in a while actually because I've been mostly focusing on my clients. So let me give you guys an update on what's been happening. So basically, because of the basically I've been kind of booked. I've been taking on like 2 regular clients a month. I mean, not a month, but a week. And these are long-term clients. So I am basically looking at their progress, checking in on them twice a week, meeting with them once a week. And essentially this means planning out their roadmap, planning out what needs to happen for them, be able to come up with plans, adjust their plan when needed, be able to spend an extra 30 minutes that day with them if it's required to explain things. And, it's a lot of planning that goes on behind the scenes. It's not just the 2 hours here. It's literally an extra, for every hour I put in here, I need at least 30 minutes in the back to try and figure out what the next best moves are for them, and sometimes it doesn't pan out. A lot of times it doesn't pan out. They may do more than what I asked. They might undershoot, and so I constantly need to adjust. So really, what you see on stream is just a percentage of it. It's like I have to set time aside as well, and that just like starts draining things on the back end for me, and I just haven't had time to be able to do it without like completely burning out. I think that's the one situation I'm trying to avoid, is just like burning out from all of this, because this is not my regular job. I'm not doing this for the money at all. I'm really just like, and maybe I'll make a video on this, but essentially the whole reason I started this coaching thing was really to prove a point. It's like to prove that like no matter what you do, there's nothing that can replace hard work. You can't spend $500 to $1,000 to replace that. That's why I make all my content for free. Like, ultimately, at the end of the day, it all comes down to executing on the right ideas, And I think it's for that reason and that level of belief that I have in myself and that philosophy that I've basically been able to have a very high, success rate on these interviews for my clients. Now, of course, there are times when it just falls through the cracks and I can't do them. Like I have a 75% across every single interview, every single one of my clients has done. And if you just take it to if those clients receive at least one offer, then that bumps up to like 85 or 90%, something massive. And if I can guarantee 75% success rate on a FANG interview, I'm pretty okay with that number. Of course, I'd love that number to go up, but there's a point of diminishing returns for me. And that's why I don't intend on making this like a full-time thing. It's just extremely exhausting. Like, it's like, of course, could I automate this, come up with a system, and come up with a course? Yeah, for sure. I definitely could. But I feel like I would be doing a kind of a disservice to both myself and other people until I found a way of doing that without keeping very similar numbers. And the reason is like I might be taking your money, but then I need to be giving you very similar results. And to my knowledge, like the whole philosophy is that you cannot buy your way to success. I believe that. And of course, it might be able to help cover the basics. But for a lot of this advanced shit, it's going to come down to the person. I can't make a course that could do that. I mean, I could profile someone and say, hey, it doesn't sound like you, it doesn't sound like you. But very few people really know themselves to that level. And that's kind of like why I'm here. Like, I'm here to basically analyze, get the human touch, analyze the person. So, hopefully that makes sense. So, I guess I'll put some Dota on for now. If there are any questions anyone wants to throw at me, feel free to.
Film school definitely help.
Okay. Maybe we should go back to Hacker News. Okay. Oh, wait. Envy's playing Ursa. Okay, I gotta watch this, actually. Oh, no! He blinked into 5 people! What is it? Okay, wait. Is he actually gonna... Oh, no. He blinked into 5 people. The fucking madman. Okay, well, I guess he has a Tinker behind him. Caesar says, I just finished rocking DP. Thanks for your tips. Towards the last section, I was able to get the solution without looking at most of the problems. Dude, I'm glad that you benefited a lot from what I had to say and my guide, man. Do you have any interviews coming up, by the way? Okay. Oh. Okay, all the ults are down. I guess that's why they're kind of like running at them. Okay, I think Sven can go. I think Ursa can play crazy now because he's got like the BKB. He just doesn't have the lockdown. Nice. Nice pick. Okay, I think he's gonna... Okay, if I was them, yeah, that's a free tower. I would try aiming for the... Okay, it's kind of awkward to run across the map for Roshan. I feel like they would just take the tower and then clear out the jungle. Right? Oh, they got another pick. Did they get another pick? No, that's not a pick. Okay, you got it. Yeah, that is a pick. Nice. Yeah, I think you take the tower, you clear out the jungle, and then you reset because Sven's gonna be able to fight. Hold on, reviewing system design. I say mid-May I'll start. Okay, man. Yeah, system design. Fortunately, we will have a stream next week focused on system design. And it's not one that I do very often on my channel, so hopefully you return back next week and you get to watch that. Oh man, okay, they just keep picking off the Mars. Holy shit! Oh, he's just gonna blink. Holy shit, they're just getting picked. Can they actually do Roshan? No, they can't. They're still stuck on the bottom side of the map. Okay, you got interviews coming up. Nice. Where at? I'm graduating this fall and plan on finishing up grokking Algo Expert. Do you think this will be early enough for new grad interviews? Fall is recruiting season. You know, holy shit, wait. I just looked one away just like for a hot second, and the Sven just died? Go do Roshan! You got 50 seconds! Fuck! Sorry. I have interviews coming up. I'm graduating this fall and plan on... Okay, so fall is the hiring season for a lot of companies, actually. And so a lot of times, I think that... we're in May now? Late April? Yeah, let's say May. And then you have until September. That's like 4 months from now. I think anyone, if they put in the right practice, can get really, really good at these questions in like 6 weeks. 4 months is plenty of time if you do it right. Okay, I guess the questions are kind of slowing down. So you know what? I'll call it a night for everybody. Hopefully you guys join me again next week. We're going to be doing a system design interview with someone else. And if there's anyone out here who has benefited from my content, whether it's my guide or my videos, please let me know, because I'd love to do an interview with you, not like a coding interview, but like a, shall we say, a winner's interview, where you get to talk about your experience, where you talk about like what has worked for you and what hasn't. I think that a lot of that type of content, a lot more positive ones, have been really helpful for a lot of people because they get to see, like, learn from an actual success story, and they know that whatever they're doing is working. So if anyone wants to come on stream and just talk about their experiences, let me know in the Discord, or send me an email at edwardchantech@gmail.com. Yeah, and so thank you, man. Good night, and hopefully I see you guys next week.